Hello everyone. We are going to understand today what happens to potassium dichromate in acidic medium. So we are going to construct a general equation in order to understand the reaction of potassium dichromate under conditions where there is excess of protons. Okay. So for this, we'll first understand the basic logic. That is, from the previous lecture videos, you might have understood that potassium dichromate, in this, the chromium that we are looking at has an oxidation state of +6. I hope you all remember it from the previous videos. If not, do check it out. Okay. Now in acidic medium, what is going to happen? Or in general, with potassium dichromate, what is going to happen? There can be loss of electron, okay, from the chromium, or there can be gain of electron. These are the two possibilities with chromium. Okay, so let's try to understand. If more electron is lost from this +6 chromium, what do we result into? We'll get +7, +8, +9, so on and so forth, depending on how many electrons are lost. If there is gain of electrons, on the other hand, we might get +5, +4. So with every gain of electron, your plus charge is going to, my bad, it becomes 3. It is going to decrease, right? So this is the basic construct of any kind of reaction where you need to know whether the primary or the main element is going to accept electron or whether it is going to lose electron. From the previous videos, you have understood that chromium is at its maximum oxidation state. +6 is the maximum oxidation state. It cannot go further to +7, +8, +9. So this becomes an invalid option. The only option that we can go for is gain of electrons. So one thing that we need to remember is when our Cr2O7 2- our dichromate ion, whenever it is in acidic medium, it is always going to show the charge on chromium to be less than 6. In particular, it is observed that it shows a charge of 3. So over here in potassium dichromate, the oxidation state is +6. And in chromium ion +3, it is 3. So you can see this has resulted only because of gain of electron. Okay. We won't be diving in further why only +3, but at least try to understand why it is going on the lower side of the plus charge. Okay. And this happens to be the major reason. This gain of electron is what makes potassium dichromate a very good oxidizing agent. If you have some confusion regarding what is oxidizing agent and how these numbers are coming into picture, kindly go through the previous video where we are discussing about chromate and dichromate ions and why potassium dichromate is a very good oxidizing agent. Let's go further and try to dissect the equation. We have got a chromate ion, dichromate ions, and we know one thing for sure, that the oxidation state is going down and it is becoming +3. What other things do we know? We are looking at this reaction in acidic medium, right? So when we are constructing any equation in acidic medium, one thing that becomes prominent is the utilization of protons. Okay, so no matter which acidic medium we are looking at, acidic mediums are bound to give surplus protons. Okay, now there's a trick in order to understand how the equation works. Whenever you see any proton coming close to oxygen, there is a very beautiful reaction known as water formation which results. Okay, so whenever you see that H plus is coming in contact with oxygen, you would always get a resultant water molecule. Okay, H2O. Now let's see how many oxygens are present. 7 oxygens. So you put 7 over here. It makes what? It makes 7 oxygens. We are good with it. 7 twos are 14. So you need 14 protons to make that water molecule. Now this is what the equation looks like superficially. We are taking dichromate ions. We are reacting it in acidic medium. We would be getting chromium at a lower oxidation state and water molecule generation. But something's missing over here. The reaction is not yet balanced. So let's try to understand what can balance it out. If you notice, chromium, we have 2 chromiums over here, but only 1 over here. So we put the number 2. Still, there are some things that are missing. The some things are the invisible entities. What are invisible entities? It means we have not yet considered electrons or charge on the reactant and product side. In any perfect equation, perfectly balanced equation, electrons need to be balanced as well. They are like those invisible monsters who can either construct or destruct your equation. So let's see over here for dichromate, we can see a charge of -2. We can see 14 plus charges over here. So together they are going to form plus 12. So our reactant side has a plus 12 charge. Let's see over here, we have 2 3s are plus 6. And any perfect compound formed or a molecule formed has a 0 charge on it. So the product has what charge? Product has a plus 6 charge. Now there are 2 ways to go for it. Okay, the 2 ways are either if you want to convert this plus 12 and plus 6 into a same number, what you can do, you can add 6 protons over here. When you add 6 protons, 6 plus 6, both of them will equal into number 12. So you would be happy. There is one problem though. The problem is when you add 6 protons, you need to again rectify the hydrogen concentration on the reactant side. And that balancing will take away all of your energy. What I usually suggest is rather than making a plus charge into the picture, you prefer going with electrons. How electrons? Let's have a look. We have plus 12 over here, plus 6 over here. Let's say I want to convert this plus 12 into plus 6. So what I'll do, plus 12 and minus 6. What will this be? Plus 12 minus 6, it results into plus 6. So what does this minus 6 indicate? Minus 6 indicates 6 negative charges. So what you are doing over here, you are constructing a reactant side which has electrons in it to balance out the electronic equation. Some might say, ma'am, you have put a negative charge over here. You have put a negative charge over here, but you are writing positive on the other side. I'm writing over here plus. It indicates what? This minus 6 indicates a numerical value. This plus 6 electrons indicates what? Plus 6 indicates something like this. Many people have this confusion, so it's all okay, always okay to go for it. Plus 6 electrons is nothing but plus minus 6. Okay, so whenever we are writing electrons, okay, we need to consider that they are bound to have negative charges. So if you write minus 6 electrons, you are actually considering it minus 6, which is actually plus 6. We do not want 6 plus, we want our 6 electrons to be plus. Okay, so that is the reason why we are considering this. Okay, and this forms your general acidic equation. Now, no matter which substrates you're adding, which elements you wish to convert, which compounds you wish to convert, always remember that this is the general equation in acidic medium. In upcoming lectures, I'll be discussing certain examples which you can accommodate along with the acidic medium to go forward. Sometimes you might even encounter that equations look tad bit different from this case. How would they look like? For example, you might have written for acidic medium Cr2O7 2 minus plus you have written 14 protons plus 6 electrons giving you 2 times chromium oxidation 3 plus 7H2. Sometimes the board might ask you to justify these in compoundic forms. How do that happen? This is nothing but written as potassium dichromate. Correct? You can write H plus as any acidic compound. So let's say we can write it as H2SO4. Electrons we need not look at right now. This can be written as chromium. See over here. We have sulfate over here, right? Let's see with it. Chromium charge 3. Sulfate has a charge 2. Cross multiply. What is the resultant product? Cr2SO4 thrice, right? So Cr2SO4, you bracket it up thrice. And water remains as water. Okay, so you can write it as water, no problem. H2O. This electron comes down as electron. Okay, now let's see what is happening. Okay, now let's try to balance it out. Potassium dichromate, yes, potassium dichromate seems like the correct or perfect one. Do we have any coefficients over here? No. So that's why there is no coefficient over here. 14 hydrogens. Already twice the number has been accepted in the compound. So what 2s are 14? 7 2s are 14. Okay. 6 electrons, nothing needs to be changed. 2 chromiums, we are settled. And 7H2O, we are settled. Now let's try to think with respect to what other compounds can be generated. We have Cr2O7, yes, we have Cr2O7. But one thing that is missing is this potassium, K2. If you see on the product side, we have no potassiums. So that becomes an imbalanced equation, right? We need something that has potassium on this side. Okay, let's see next. 7 2s are 14, 7 2s are 14. We are happy with it. 7 times sulfate. What is this? 7 times sulfate, of which 3 times sulfate has been utilized by chromium. Okay, minus 3 times sulfate utilized by chromium. So how many more sulfates remaining? 4 times sulfates are remaining. Yes or no? This is the basic notion with which we continue our reactions, you know. Getting a proper idea of what is going on is pretty important. So let's see, we have potassium, we have sulfate. Let's see what can happen next. Okay. Now with this, what we are going to do, we are just taking a potassium, we are taking a sulfate. Happy? Potassium's charge is 1, sulfate's charge is 2. Cross multiply. You are bound to get K2SO4. Fine. K2SO4. You get your potassium sulfate. Now, one might question that, ma'am, remaining sulfates, where do we go with them? So for that, you need the other reactant. So suppose you want to convert iodide to iodine, or you want to convert ferric to ferrate, something like that. Okay. That time, the excess of sulfates also get utilized, or we get at least some amount of more potassiums from the reaction. But this is the general construct. What I generally ask my students to remember, forget about every other compoundic form. Remember one thing for sure, you learn this equation properly. For acidic medium, at least learn this equation properly. Rest all, according to the conversion, the secondary conversion, you would be able to satisfy the equation. So if you want to understand how we use it with different compound conversions, please make sure to watch the next video. Another hint of knowledge that I want to provide is, can you see that dichromate is accepting electrons to get into the lower oxidation state, right? What is this? This is gain of electron. And we know who gains electron? Only those who are oxidizing agents. So while even constructing the equation, knowingly, unknowingly, we got that gain of electron on the dichromate side itself, indicating fully that potassium dichromate is an oxidizing agent. If you have any doubts, please put it in the comment box. If not, signing off. Bye.